After taking the E-Day assessments this week over Chapter 18, Sections 1 and Section 2, I've had people ask me, hey, I didn't understand a question on the test, or maybe got one wrong and don't know what the right answer is. So I just wanted to go over the correct answers to that. And what I have in front of us here is the worksheet that we used to create those little e-assessments that you took. So it doesn't look quite the same. If you would like a copy of this worksheet, if you go to modules, this is called worksheet number 1 in modules. You can print it if you're like me for having a hard copy of something. The first question you had to answer in assessment on section 1 was list 3 ways that reaction rates can generally be increased. And those would be increase the temperature, have smaller particle size, or have higher concentration of the reactants. And then the second question on that assessment was ethyl acetate reacts with a solution of sodium hydroxide and water to form sodium acetate and ethyl alcohol. You really didn't need all that information. What they says was suppose at 25 degrees C 2 moles of ethyl acetate reacts completely in 4 hours. How would you express the rate of reaction? We have to go back to the definition of the rate of a reaction. The rate of a reaction, it's the change in the reactants over time. And we went from having 2 moles of ethyl acetate to 0, so that's 2 moles was the change of the reactants, and it said it happened in 4 hours, so 2 divided by 4 is 0.5 moles per hour would be the rate of this reaction. And then number 3 and number 4 on the quiz were how would the following actions likely change the rate of the reaction in problem 2, this reaction we were just talking about. A, the temperature is lowered to 4 degrees C. So if you lower the temperature, you're going to make the rate slower. And then B, the concentration of sodium hydroxide, which was one of the reactants, is increased. That's going to make the rate faster. And then question number 5 that you had was ethyl acetate and water are not miscible, means they're separate like oil and water would be. Thus the reaction in problem 2 only occurs at the interface of the 2 liquids. What would be the effect on their action of adding a solvent to make the reaction homogeneous? Well, if you made those 2 solutions homogeneous, in other words, you made them mix, then the reaction would go faster because the reactants would have more contact with each other. Then question 6 on the electronic test you took used a potential energy diagram like this one. These always start with the reactants, and then there's at least one hump, and then products. Okay? The hump being the activation energy barrier that you have to go through to get from reactants to products. Okay, the first question you were asked, which was number 6 on your quiz, was is the above reaction endothermic or exothermic? Well, the energy of the reactants was here. The energy of the products is less. So where did that energy go to? It had to be given off to the surroundings. So that would be an exothermic reaction. The energy of the products is less than the energy of the reactants. Okay, then the next question you were asked was what letter represents the potential energy of the reactants? Well, when it says potential energy, it's really meaning the energy from the baseline. So the energy of the reactants would have been letter B here. These are the reactants. Then the next question was what letter represents the potential energy of the products? Well, the products' potential energy would be letter F. These are the products, and this would be the energy they have. Then question number 9 on your quiz was what letter represents the heat of reaction? Delta H. Okay, so the heat of reaction would be the difference between the energy of the reactants and the energy of the products, and that would be D. Right here would be the heat of reaction. And then it asks you what would the value of that be? Well, on this graph, the reactants have an energy of 150, and the products have an energy of 110, so the difference between those 2 numbers would be 40. And since we know this was an exothermic reaction, minus 40 was the heat of reaction for this. And then number 11 on your quiz said, what letter represents the activation energy of the forward reaction? Well, the activation energy is the difference between the reactants, where you're starting, and this hump that you have to get over. So that distance would be represented by this letter A here. So A represents the activation energy of the forward reaction. And then what letter represents the activation energy of the reverse reaction? Let's think about what the reverse reaction means. In the reverse reaction, these are now the reactants and those are the products. So you're starting here and you have to get over this hump. So E represents the activation energy of the reaction going this way, the reverse way. And the value of E would be 110 is where you're starting from, and looks like 210 is where you're going to. So that is a difference of, let's see, that's a difference of 100. Okay, and then the next question was, what letter represents the potential energy of the activated complex? Well, the activated complex is up here at the top of the peak, so the energy at the top of the peak would be represented by this letter C. Okay. And then the next question was, is the reverse reaction, so starting with reactants here and products here, if you're going this way, would the reverse reaction be endothermic or exothermic? Well, the products going this direction have more energy than the reactants do, so they had to gain that from the surroundings, so it would be endothermic. Actually, if you have a reaction, you're talking about a forward direction and a reverse direction, if one of them is exothermic, the other one has to be endothermic. Okay. And then the next question was, if a catalyst were added, what letters would change? You have to remember what a catalyst would do. A catalyst would lower this activation energy barrier here. It would lower this down. So everything that was measured from the top of this peak would change. Letter A was measured to the top of the peak, letter C was measured, and letter E was measured to the top of the peak. So A, C, and E were the three answer choices for that part.